how do I use function notation to get my output values? If I have f of 200 equals negative 3x plus 4, what do I do now? In this lesson, you will learn how to evaluate functions by using specific input values. Let's review. A function's output depends on its input. For each domain value that I plug into a function, I evaluate the function using that domain value in order to get my output value. If I plug in 1 for x, then I get 3 for my output, or for f of 1. If I plug in 2 as my input, I get 5 for f of 2. And if I use 3 for my input, I get 7 for f of 3. Again, we know that this is a function because each input only has one output value, where my input determines what my output will be. A common misunderstanding is thinking that input values are always numbers, but input values are not always numbers. Input values can be numbers, they can be expressions, and they can be other functions as well. Again, input values do not just have to be numbers. Well, now that we know what our input values can be, let's show a few examples of how to evaluate functions for these input values. We'll start by looking at a function whose input is 200, and the function we'll use will be f of x equals negative 3x plus 4. We will use this input value with this function to determine my output value. So what we do is we take our input and replace both x's with 200. And then we simplify. Negative 3 times 200 is negative 600, and negative 600 plus 4 is negative 596. You'll notice that I don't simplify anything on the left because f of 200 is just my output. So now we can see that my output, f of 200, is negative 596. Well, let's try one where my input is an expression. My input will be x plus 2, and I'll use the same function as before, negative 3x plus 4, and then I'll use this input with this function to determine my output. We will replace both x's with x plus 2, and then I simplify. Negative 3 times the quantity x plus 2 is negative 3x minus 6, because you have to distribute your negative 3 to each term in the parentheses. And then I combine like terms to get negative 3x minus 2. Therefore, my output, f of x plus 2, is negative 3x minus 2. Well, what am I supposed to do if my input is another function? Again, we'll look at the same function as we did before, but this time we'll input another function, g of x equals 5x minus 12, to get my output. All I do is I replace the x in f of x with the label of the function I'm using, which is g of x. And then I replace the x in the expression with the actual value of g of x, which is 5x minus 12. And then I do what I did before. I simplify. Negative 3 times the quantity 5x minus 12 gives us negative 15x plus 36, because we distribute the negative 3 to each term in the parentheses. And then I combine like terms by adding 36 and 4, and so f of g of x equals negative 15x plus 40, which now becomes the value of my output. I want to clarify one more misunderstanding. Some students think that f of 200 equals negative 3x plus 4 is the same thing as 200 equals negative 3x plus 4, but this is not the same thing. We have to treat f of 200 as its own variable, even though it has a number in it. So just remember that if you see f of 200 equals negative 3x plus 4, that the 200 is just telling you that that's what your input value is, not your output value. And then we use that 200 to simplify the rest of the expression to get our output value. Also, when you have an input value that's not just a number, it's an expression, it's common for students to think that we're trying to solve for x. But when your input's an expression, you're not trying to solve for x. You're just generating another expression. And then we can choose values for x like we did before after we've simplified. So remember, when you see a function whose x value is an expression, this is still your input. And then we simplify the expression with the value of the input to get my output. In this lesson, you have learned how to evaluate functions by using specific input values.